This lesson is an introduction to complex numbers for secondary 2. So first we're going to talk about the case where you have the square root of -1. We've always been told before that that's an error, that it's not real, and that's true in the real number system. So we're going to talk today first of all about the imaginary number system. So we already know about the real number system, and that includes all your rationals, irrationals, fractions, decimals, whole numbers, natural numbers. But we're going to talk about another set of numbers, which is the imaginary number system. I kind of think the word imaginary was an unfortunate choice of words because people think it means like make-believe or made up, and that's not what it is. French mathematician René Descartes suggested the imaginary unit I be defined so that I squared is equal to -1. So if I squared is equal to -1, that's the only number that you can square and get a negative, because we know before that we can't square anything and get a negative number. And that's true for real numbers. René Descartes, by the way, is also the one that invented the Cartesian coordinate system that we know as our XY axis and being able to graph things with an XY coordinate plane. The imaginary unit, back to I squared equals -1, it allows us to solve problems that we wouldn't otherwise be able to solve, and so that's what we're going to talk about today. The complex numbers are both a real number part and an imaginary number part, and so the way that we write the standard form of a complex number is the real part plus the imaginary part. So A plus BI, so A is something like 5 or -2. BI would be something like 3I. So an imaginary number would be something like 4I, and then if we add a real number 5 to it, then this would be a complex number. Some things that we want to memorize, and if you'll know these things, then you'll be able to do anything with the unit I. And so first and foremost, this one right here, I squared is equal to -1. And so if you have a -1 and you're taking a square root, then it's equal to I. So that takes us to this other one. So I to the first power is equal to the square root of -1 because I to the second power is equal to -1. And then if we take I to the third power, I to the third power is the same as I squared times I, which is -1 times the square root of -1. So that's -I. And then I to the fourth power is I squared times I squared, so that's -1 times -1, and so that's 1. So what happens when we have this situation, we've got these numbers and these patterns, and so I like to show this. So if I've got I squared is equal to -1, I is equal to the square root of -1, I to the third power is equal to -I, and I to the fourth power is equal to 1. I to the fifth power, that's going to be I to the fourth times I, so that's 1 times the square root of -1. I to the sixth power, that's I to the fourth power times I squared, and so that's going to be 1, which is I to the fourth, times I squared, which is -1, so that's -1. You notice that these start cycling through, so we start seeing the same things over and over again. So I to the seventh power is going to be -I, and so it happens that it just goes through cycles of 4, so every 4 with the exponents is going to repeat the cycle. So let me back up. So if we have something like this, we can actually use that to find any I to any power. So if I do something like I to the 38th power, I just ask myself, how many cycles of 4 does that have to go through? So 38 divided by 4, that's 9 with a remainder of 2. So it's going to go through the cycle 4 times. And so going through once, twice, 3 times, 4 times. So 9 whole times, and then we're going to go remainder 2. So that's going to be -1. And if I say I to the 112, 112 divided by 4, that goes in evenly, and so I can find out how many times it goes in exactly, but because it goes in evenly, I know it goes in, 28 times, 28 full cycles. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to end here on 112, and so that's going to be equal to 1. And so you can figure out any I to any power because of that cycle of 4. Okay, so for our first example, if we take the square root of negative 32, we can use the imaginary number I to do this. And so before, when we've done this, we say no real numbers, and there aren't any real numbers that would satisfy this. But what we can do now that we know imaginary numbers is we can say square root of negative 32, that's negative 1. And then 32 is 4 times 8. So I'm doing the 32 part the same as we've done before, and so I take out a pair and take out a pair. So this is coming out, this is coming out. So I've got 2 times 2. The thing that's different, though, is the square root of negative 1. I know what the square root of negative 1 is now. It's I. I'm still left with 2 underneath the radical. So I'm going to have 4i square root 2, and that's equal to the square root of 32. So this is an imaginary number, and that's the solution to, that's the solution to the square root of negative 32. Okay, we're going to write the complex number, this, in standard form. So the square root of negative 4, if it was the square root of 4, it would be 2. But the square root of negative 4 is 2i plus 3. That's just coming from there. In standard form, we're going to write the real number part first, and then the imaginary unit. So that is how you would write that number in standard form. So these are the same numbers, but one is in standard form and one is not simplified. Going back to this first page right here, if I have I could also say that it's equal to I. And then I squared is equal to negative 1, and so this is the one that we have to memorize. And then I could say I to the third power is equal to negative 1 times I, so negative I, and I to the fourth power is equal to negative 1 times negative 1, which is 1. So that's another way that I could do that cycle, and that actually is helpful when I get to the next problem. So I to the fifth, if I just say I to the worst is I, and then I've got I squared, which is negative 1. Then I've got I to the third, which is negative I, and I to the fourth, which is 1. And then I to the fifth, I'm going to come back there. So the answer to this question is I. That's what I to the fifth is. For the next one, I to the 95th power. Because this goes in cycles of 4, I'm going to first think, what is 95 divided by 4? And since that's 23.75, that means it's 23 with a remainder of 3. So I'm going to go 23 whole cycles and then 1, 2, 3. So my answer is negative I. Okay, the next one, I to the 7,321st. So I'm going to say 7321 divided by 4. And that comes out to 1830.25, so remainder 1 out of 4. So in my cycle of I and then negative 1 and then negative I and 1, I'm going to go through 1,830 times and then remainder 1, so I'm going to end up at that one. So my answer to that one is I. Okay, the next one, we're going to perform the indicated operation. So we're going to be adding complex numbers. So we've got one complex number plus another complex number. And so you're going to actually treat these just like you would any kind of polynomial. So we're going to say 17 minus 2i plus 4 plus 5i, and you just combine your like terms, so to speak. So we're going to combine our imaginary parts, and we're going to combine our real number parts. So 17 plus 4 is 21. Negative 2i plus 5i is 3i. That is in standard form, so we've got our real part and our imaginary part, and that's going to be my answer. So pause the video and do the next example, and then come back and see if you did it right. So you should have done 3 plus 2i minus, and then you're going to have a negative, so that's going to be plus 8, and then minus 2i. So combining my like terms, my real number parts is going to be 11. My imaginary number parts, that's going to be 0. So the answer to this one is just 11. Okay, pause the video and try this next one. So make sure that you watch your signs when you do this. That's the number one thing that goes wrong for people. We're now going to combine our like terms. So I've got my real number part, so 12 minus 2. And then I've got my imaginary number parts, 5i plus I. So my answer is 10 plus 6i. That is in standard form. Okay, the next example, we're going to be distributing. And so again, watching signs is a really big important thing, but it starts out by working the same way that we're familiar as if it was any letter. not just imaginary numbers. So I'm first going to start out by multiplying everything just as I would if it was x or y or p, or it doesn't matter. So I'm going to have 8i minus 12i squared. Now here's where it goes differently. We know that I squared is equal to negative 1, so instead of writing I squared there, we're going to have 8i minus 12 times negative 1, which is 8i plus 12, and so to rearrange that in standard form, I'm going to have 12 plus 8i. Okay, now the next one, distributing, we're going to have a binomial times a binomial. So again, the 4 times the 5, the 4 times the 2i, the negative 3i times 5, and the negative 3i times positive 2i. So when you start to go to combining like terms, you've only got the 20 as your real number part so far. These two right here are both i's, so I can put those together. But then the last part, the negative 6i squared, you need to remember that that's a negative 1. So I've got negative 6 times negative 1. The thing that people do wrong here is they'll just put minus 6. It's actually negative 6 times negative 1, so it's a plus 6. So be really careful with that. Now I can combine my two like number, or my real number parts. So I'm going to have 26 minus 7i. Okay, the next example we're going to see is with radicals. And so when I have the square root of negative 6 times the square root of negative 2, we're going to think about this as, because I can't do that by itself, and I can't do that by itself. By themselves, like we know how to do that if there weren't negatives, but the negatives make this work a little bit differently. So the first thing I'm going to do is I'm going to call the square root negative 6, I'm going to call that I squared, because that's negative 1 times 6, times I squared times 2. And so when I do that, I can take the square root of I squared, which is I, and the square root of I squared is I. Now I can deal with this as I'm used to dealing with them like I did before. So I can do I times I is I squared, and square root of 6 times square root of 2 is the square root of 12. And that means that I squared is negative 1. The square root of 12 is 4 times 3. So I can take out a pair of 2's. 1 times 2 is 2. So this is the correct answer as a simplified version. Now one thing that's a little bit confusing is we know when we've worked with radicals before, we know that you could do like square root of negative 6 times negative 2 because they're both under the radical. It actually doesn't work the same way, and if you did that, you'd have square root of positive 12, which is different than what we have otherwise. And so you just have the 2 square root 3 and not negative 2 square root 3. And so it doesn't work the same. And one year I checked with somebody that was a mathematician, and they explained that because you've got an unreal number there, you can't use the real number rules for this. So it doesn't work with imaginary numbers or non-real numbers the same way. So the radicals don't operate quite the same way if you've got imaginary components. Okay, example number 5. Okay, example number 5, we're going to talk about something called the complex conjugate. And so we use conjugates to simplify numbers that have imaginary parts or complex numbers because there are certain rules that go along with simplifying them. And so as part of what we do in this unit, we'll learn about this, and also in your honors module, you'll learn about this as well. But we need to know what a complex conjugate is. So if we have the complex number 4 plus 3i, the complex conjugate of that is 4 minus 3i. So it's not exactly the opposite, because you don't take the opposite of the real number part, but you just change the sign in the middle. And the reason why that's a complex conjugate is because if you take a number times its complex conjugate, and you multiply them together, you will have a real number. So we use this as a tool. So kind of like when we are simplifying other types of numbers and we like multiply by a square root 2 over square root 2. We're not doing anything wrong with that, but we're using square root 2 over square root 2 as a tool. And so we're going to use the conjugate of a number as a tool. And so as we move further in this unit, we'll see like how do we use that. On your homework, you'll be asked to find the complex conjugate, but that's really all you have to do right now. And so if it asks you for the complex conjugate, you're just changing the sign in the middle. So if you had like 2 minus 5i, the complex conjugate would be 2 plus 5i. They're not equal to each other, so don't write that it's equal to, but the complex conjugate would be the 2 plus 5i. Okay, so you could just write the answer there. Okay, the next one, we're just going to practice simplifying a lot of imaginary or complex numbers. And so 3i squared, that's the same as 3 times negative 1, so it's negative 3. So I'm going to show you one more, and then you can pause the video and do as many as you feel like you can do before you have a question. And then when you have a question, then go back to the video and see what you find out. So I'm going to have negative 4 times I squared, so that's negative 4 times negative 1, which is positive 4. And that's what that's equal to. So pause the video, do as many of these problems as you feel like you can, and then when you get where you have a question, come back and then check your answers. 8i to the 6th. So I can look at this a couple ways. I can think about that cycle of 4 that I had before, the I, the negative 1, the negative I, and the 1. And I can know that I have a remainder of 2. So 6 divided by 4 is 1, remainder 2. So I'm going to be at negative 1. So this is 8 times negative 1. So that's one way that I can think about this. Another way, in case you struggle with that a little bit, in my head I kind of feel like that's a little bit less easy, but I can look at it, I can break it down like this. I to the 6 is I to the 2nd times I to the 2nd times I to the 2nd. That's 8 times negative 1 times negative 1 times negative 1. And so I can do that problem just as easily. Just kind of depends on how your brain thinks about it. Okay, this next one's distribution. And then don't forget that the I squared is negative 1, so I'm going to have 15i plus 10 times negative 1, so negative 10 plus 15i. When you write your answer, you have to write it in standard form. So like on your quiz, on your test, you will have to write this in standard form, and if you don't write it in standard form, you'll get it wrong. If you write it as 15i minus 15 or 10, yeah, that's equivalent, but it's not in standard form, so you will get that marked wrong. Okay, number 10, we've got 7i, and then that's all to the 2nd power. That means 7i times 7i, so that's 49i squared, which is 49 times negative 1, which is negative 49. Now you might notice that if you have a graphing calculator, it does operate with imaginary numbers. So you will find a button, and I'm just telling you this because some people already have figured it out, but there is a button that will calculate with your imaginary unit. However, because of that, you will not be allowed to use a graphing calculator on this test. So just so you know, don't rely on that. You have to be able to do this. Okay, the next one, number 11, we're going to have positive 10 I squared, so that's going to be negative 10. Number 12, we're going to have positive 7i minus 8i squared. I squared is negative 1, so I've got 7i minus 8 times negative 1, so that's 7i plus 8, but don't forget to write it in standard form. And that might be a hard part for you to remember, to write it in standard form, so you're going to have to remember that. Okay, the next one, we've got 3 different numbers being multiplied together, so just do 2 at a time. So I'm going to have negative 20 I to the 2nd, which is positive 20, and then I'm going to multiply by 2i, so that's 40i. Okay, number 14, negative 3i times 3i. These are actually conjugates of each other. And because it's like 0 minus 3i and 0 plus 3i, and so they're actually complex conjugates. When I multiply, I'm going to have negative 9i squared, which gives me a real number of positive 9. And that's what happens when you multiply a number by its conjugate. You'll get a real number. The square root of negative 128, so remember that we have to treat this a little bit differently. You're going to take the negative part and you're going to turn that into the imaginary unit, I squared. And then 128, you can break that one down. You can break that radical down. So I'm going to say that's 64 times 2. And so I'm going to have I squared, so I times I. 64 is 8 times 8, and then times 2, so I can take out a pair of i's, a pair of 8's, and then 2. Now when you write this in a radical, the standard form for that is the coefficient comes first, then the I, then the radical. Do not write it like I 8 square root 2. Do not write it like square root 2i8 or anything like that. So it has to be written in this way. That's how you write an imaginary number of that nature. Okay, number 16, make sure that you can do this one. So I'm going to break down the I squared as -1 first, and then 48 is 16 times 3. So the square root of I squared is I, the square root of 16 is 4, and then I've still got a 3 in there. Okay, the last problem, there's a lot going on here, so I'm going to start piece by piece. So -1 is I squared. 600 is 6 times 100. A to the third is, I'll just write it out like this, A times A times A, and then B to the second. So when I go through and take out pairs, the square root of I squared is I. The square root of 100 is 10. I can take out a pair of A's. I can take out a pair of B's. What I have left is I have a 6 and an A. Now, how do you write that in standard form? So what you do, the imaginary unit is going to come right before the radical. And then the 10AB will come before that. So the I is the one that's going to come right before the radical. Everything else will go in alphabetical order. And then underneath your radical, you go coefficient and then alphabetical order after that. Okay, you should now be ready to do your homework. So on your homework, you're just going to do more of the same thing where you just do a lot of multiplication, adding, simplifying. And so just make sure that you're pretty fluent in doing that. And then as we move on through this unit, we'll keep working with imaginary numbers and complex numbers, and that's also with your module, you'll be doing that. And then when we get into the next unit, we'll be seeing how we can use that for other types of math problems.